All right, team, listen up. For the past 25 years, I've been in the trenches architecting electric powertrains for race teams just like you. And I can tell you, you don't win Formula Student with a fancy motor or light chassis alone. You win by mastering energy. And the absolute heart of that mastery, it's the battery management system. So today, we're not talking about just another component. We're talking about the blueprint for your championship potential.
I want this quote burned into your minds. We are not here to build a simple safety device. We are engineering the central nervous system of our race car. That gap between finishing in the middle of the pack and standing on the podium, it's measured in joules. And the BMS is the gatekeeper to every single one of them.
So here's the first and most critical point. We have to shift our entire mindset. Most new teams, they approach the BMS playing defense. Their only goal is, can we pass technical inspection? That is a losing strategy, plain and simple. Our mindset has to be pure offense. We are designing a BMS to do one thing: win the endurance event. Every single decision we make from this moment on is driven by that one goal.
Okay, let's get into it. To build a winning system, you first have to define what winning actually looks like. We need hard engineering targets. You can't hit a target you haven't defined, right? This is where we stop thinking like an average team and start operating like a world-class organization.
Now look at these numbers. This is what's so fascinating. The gap between average and world-class isn't small. We're talking about massive gains. We need to be half a kilogram lighter, which is huge, twice as accurate on voltage, and our state of charge error has to be 5 times smaller than the competition. And reliability? Forget measuring it in hours. The only number that matters is 0. 0 false positives. Because one tiny hiccup in the endurance event means a DNF. Did not finish. Game over. These are our targets.
Let's move on. I want to talk about the rule book. A lot of teams look at the rules and just see a list of obstacles, things they have to do. That's the wrong way to look at it. I see a playbook. If you master these constraints, you don't just achieve compliance, you uncover a competitive edge that almost everyone else will miss.
And this is a perfect example. For the 2026 season, this one little sentence in Rule EV 5.8 completely changes the game. Your temperature sensors must physically touch the negative terminal of the cell. You can't just stick them on a nearby bus bar anymore. This one single constraint has a massive ripple effect on our entire mechanical and electrical design.
So what does that actually mean for us? Well, for starters, those old school rigid PCBs that you just lay over the cells, they're obsolete now. We have to be more creative. Think flexible PCBs or maybe custom spring-loaded sensors. It makes our modules more complex, but here's the strategic play. The rule says you only have to monitor 30% of the cells. We're going to monitor 100%. Why? Because that gives us a perfect thermal math of our entire battery. It's invaluable data to prove our cooling system works and gives our driver the confidence to push the car to its absolute limit.
All right, this brings us to what is, without a doubt, the most important decision we will make in this entire process: the system architecture. This one choice will set the path for our system's weight, its reliability, and ultimately its performance. If we get this right, we're on a path to the podium. If we get it wrong, we'll be chasing ghosts all season. So here are our options. A centralized system? It's a non-starter. Just the weight of the wiring harness alone will kill us, not to mention it's a reliability nightmare. Wireless? It's cool technology for sure, but it's just not ready for the brutal electromagnetic chaos of a race car. So the answer is clear. It's non-negotiable. We're going with a distributed architecture. It's the industry standard for a very good reason.
Let me quickly break down what distributed means. Think of it like this. We have one central master unit, which is the main brain. It does all the heavy thinking and talks to the rest of the car. Then, on each of our battery modules, we place a small slave board. These slaves are like nerve endings. They take measurements right at the source, from the cells themselves. Then they send that data back to the master over a super robust, noise-proof communication line. It's clean, it's efficient, and it's tough as nails. Okay, so we've got our architecture locked in. Now we need to drill down into the nitty-gritty. We have to arm the system with the right components. These hardware choices are the foundation. Our entire performance is going to be built on top of them.
The analog front end, the AFE, that's the real heart of the BMS. It's the chip that does the actual measuring. Now, you might see that TI chip and think the higher accuracy is better, but my recommendation, especially for a new team, is the ADI LTC681-3. This chip is battle-tested. It is the gold standard in Formula Student. Its reliability is unquestioned. For our first car, reliability is king, period.
Next up, cell balancing. Active balancing sounds really cool, right? You move energy around from full cells to empty cells. But the reality is, the hardware is complex, it's heavy, and it's expensive. And for a 30-minute race, the energy you save is practically nothing. So, the winning choice here is passive balancing. It's simple, it's light, and it is dead reliable. We'll just design ours to handle a higher current, so we can balance faster in the pits, which is a huge advantage on race day. Now, current sensing. Every single calculation we do about energy starts right here. A basic Hall effect sensor is fine for a backup system, but it drifts with temperature and it's just not accurate enough for what we need to do. The strategic choice, the one every single championship team makes, is a smart shunt. The accuracy is literally an order of magnitude better. This is not a component you cheap out on. This is where you invest in precision. So we've just laid out a plan for a world-class hardware platform. But great hardware is just potential. It's just a pile of parts. It's the software that unlocks that potential and turns our BMS from a simple monitoring device into a race-winning weapon. This is where the real magic happens.
And it all comes down to answering this one critical question. How do you let your driver use 99% of the battery's energy, pushing it to the absolute edge without the BMS panicking and shutting everything down? The answer isn't in hardware, it's in advanced algorithms. The tool we're going to use is called an extended Kalman filter, an EKF. Forget just counting energy in and out. An EKF is predictive. It uses a digital model of our battery to understand not just how much energy is left, but to predict how the battery is going to behave under extreme stress. And it's constantly self-correcting, giving us a true dynamic picture of what's happening inside those cells. And this is the result. With a well-tuned EKF, we can get our state of charge error down to less than 1%. That level of precision is the key to everything. It gives us the confidence to let the driver drain that battery right down to the very last drop, knowing our numbers are rock solid. That is how you win the endurance event.
The final piece of the puzzle, the next level up, is state of power prediction. This is the ultimate offensive tool. Our BMS won't just know how much energy is left, it will be in constant communication with the motor controller, telling it the exact maximum power it can safely pull for the next 10 seconds. The system basically rides the red line of performance automatically, without the driver ever having to fear a sudden power.
And that brings us to our final strategic decision. All this technology, all of this potential, it all hinges on one choice. And this choice will define this team's engineering culture and its future in this competition. The decision is simple. Make versus buy. You can buy a commercial unit off the shelf, but you know what you're getting? A heavy, expensive, black box that you can't optimize or control. Building it in-house? Yes, it's a huge challenge. It takes dedication, but it is the single best way to show the judges what you're made of. A custom BMS tailored to our car is a core competitive advantage that nobody can copy. So the imperative is clear. We make. So I'm going to leave you with this final question. I want you to think about this with every decision you make from here on out. Is your BMS going to be a safety box that you're forced to install just to pass the rules? Or is it going to be the weapon you choose to win with? The choice is yours. Let's get to work.